This video is how to apply power to a wheelchair motor. The nice thing about a wheelchair motor is we have the brake on the motor. That's great for different applications. But how many volts does it actually take? This is a 24 volt motor, so theoretically, of course, it should work at 24 volts. But of course, we want to vary the speed, and also how many volts does it take to actually activate the brake? So, for example, we have the brake activated. Well, it's kind of hard to see all that, but through the wires there, just trust me on that one. We have the 4 wires coming off the motor, 2 large wires off the wheelchair motor itself, and then 2 smaller wires that go to the brake assembly here. Now, there's lots of videos on how the brake actually works, so we're not going to bother getting to that. But nobody says anything about what actual voltage is required to activate the brake. So we're going to find that out here now. So I've got this set up with our variable power supply, and I've got the brake activated, which means released off a 24 volt power supply there off those batteries, and then I'm running an additional power supply to the, that out just a little bit, to the actual motor. So I've got one power supply with the batteries on the brake, second power supply on the actual motor. So when we start winding up, you can see that the motor's starting to turn already at just 3 volts. Well, I'll probably get it down to 2.5 volts actually. Yeah, there we are. So we're only 1.5 volts. The motor is actually still turning at 1.5 volts. So we can crank it all the way up. So there's 12.7, crank it all the way up to, there's 24, 25 volts for full speed. Okay, so at 12 volts, for example, 11 volts, motor's still turning pretty good. Okay, so that's the actual motor part. It'll start turning at just 1.5 volts. For ultra low speed, all the way up to the 25. And if you notice how many amps, this is just freewheeling, of course, yeah? So if we put a load on that, of course it's going to increase. So we're only doing 4 amps at 21, let's bring it up to 24 volt. 4.1 amps. We start putting a load on it, of course that's going to increase a lot. And down at 1 amp, just for, or 1 volt for example, 1.5 volts. Okay, there's 2 volts for example. We're still doing 1.6. And still got plenty of power there, doesn't it? Okay, so now we're going to knock that back to 0. And we're going to take the 24 volts off of the brake. Here it click. And we're going to swap all these leads around the other way around. Okay, so we've got brake is going to go on here. And the motor is going to go on here. We have to activate the brake before we turn the motor on. Okay, so you will be able to hear the click of the motor, click of the brake when that is active. Okay, we're at 6 volts and the brake still hasn't activated. 9 volts, still hasn't activated. 12 volts, still hasn't activated. Oh, there we go. So it's the brake kicked on at 14 volts. Okay, let's knock that back and see when it turns itself off. Okay, we're at 5 volts and the brake is still active. Oh, there we go. So 12, what did I just say? So it was 4 volts when it went off. And 13 volts for active. So that means we cannot just connect the brake to the motor in parallel. Yes, in parallel. Because when we're down at 1 volts or 2 volts, sorry, 2 or 3 volts, at ultra low speed, it's not enough power to activate the brake. We're going to need at least 13 volts, but at 13 volts, the motor is at pretty well half speed, and maybe that's too fast. So again, this all makes a big difference there, yeah? So that means we need two different power supplies for the motor if we want to vary the motor speed. Yeah? We need the full 24 volts, well, at least 13 volts for the brake, but that to me doesn't sound like it's very positive. That click doesn't sound like it's hammering in to fully disengage. So let's try that. We'll connect up we'll disconnect the brake, and we will connect up the motor. Whoops, I got that connection wrong. Whoops. Let's try that a different way. All right, what's happening here? Yes, that's a negative, that's a positive. And the brake. Okay, so we'll knock this back and see if we can activate the brake. Or just disengage the brake. There we go. There's the brake active. And we're back up to, well, feel the current. The wires are burning. The little wires there. Oh heck! I think I just melted the wire. Yeah, I just melted the wire. Damn it. Shoot. Okay, these little Chinese leads are not very good. Yeah, I just melted the wire inside there. Okay. Okay. You get. Boy, oh boy, oh boy. It's not very successful, was it? Okay, it was only 4 amps, and it melted melted one of the wires here. Okay, we'll let that cool down for a moment, and we'll put that back on. Yep, it looks like I remember which one now. But there we go. That one's still working, but that one is not. So I just melted this one off. So these connections are only crimped in place, they're not soldered. So it's no wonder it failed, yeah? Okay. Well, yes, we were going to test the... All right, let's put that one off to the side because I know that doesn't work. Let's find out how many amps the brake needs. So let's disengage the brake. There we go. And 0 amps. So to engage the brake, we're starting to get a bit of load on the magnet. Okay, so now the brake is engaged and we're only 100 milliamps, yeah, 0.1 amp. So if we run the motor at 24 volts, 25 volts, the brake itself is only consuming between 2 and 3, 0.2, 0.3 amps, yeah? So 300 milliamps at the very most, just for the brake. So that's quite low current, just for the brake here, right? So let's connect up, there's my yellow one. So let's connect up that green one, and we'll confirm that is going to turn. Right, my white wire here melted slightly, so we'll do that quickly before it melts. Okay, we're still 0.2 amps as it's turning. Okay. Alright. This power supply is a pulse width modified power supply, and I just happen to have that one in my box, so I burnt the other one up. Let's connect up. Let's take that off, take that off, take that off. And we're going to, what are we going to do here? Let's go from here to here. Negative there, positive there. Can you see that? I think I'm off screen, aren't I? Yes, I am off screen. Let's go back out here a little bit. Okay, so now we have this going through to here. And this is the output of the PNW water supply. So let's connect those there and there. Okay, so now we're running the break off of this power supply and this power supply. If you look at there. This frequency doesn't make a difference here. Okay, I can feel the wires heating up here, so I'm going to turn that off. There we go. I can feel the heat coming off these wires. Even though it's only running at 4 amps, but these wires are so thin, it doesn't take much to burn them up. Okay, so there you go.